Today we continue our discussion of rational expressions. Specifically, today we're going to be talking about products and quotients. So just like we did last video, I'm going to start with some steps to consider. The first thing I want to look at is because we have products and quotients, or multiplication and division, I want to talk first about what exactly that's going to do for us while we're simplifying. So with multiplication, like example 1, where they have this little dot in between, basically they're saying multiply the two rational expressions together. And essentially what that means is I'm just going to extend the fraction bar. So this is now going to become one big fraction. So really we could put parentheses around this to make it a little clearer. But as of right now, all of those things are being multiplied across the top and all of them across the bottom. Division is the one that's a little bit tricky, and maybe you'll remember this phrase from another course, something to the effect of same, change, flip. And what that means is we're going to keep the first fraction the same. We're going to change from division to multiplication, and we're going to flip the second fraction, because division is really the same as multiplying by the reciprocal. So if you think about it, like if you had 4 divided by 2, that's really the same as multiplying 4 times 1/2. So we kept the 4 the same. We changed the divide by 2 to multiply by the flip, which was, instead of 2, it was 1/2. So we'll see an example of that when we get down to examples 3 and 4. Then after that, once you convert it to a multiplication problem, if it's not already one, then we're really just looking at simplifying rational expressions the way we did before. So as a refresher, at that point, we're going to factor everywhere. So we're going to factor the top, the bottom. We want to make sure we get it down to as many factors as possible. And the whole purpose of doing that is to cancel common factors. So if we have an x plus 2 on the top and an x plus 2 on the bottom, we can cross those off. Okay, so let's take a look at example 1. Get rid of these parentheses so we can see a little clearer here. And basically, again, because this is a multiplication problem, first thing I'm going to do is just extend this. So really it's one big fraction problem altogether. So what I want to do is think about what factoring techniques do I need to use. Well, 2x minus 5, it's 2 terms. There's not a GCF, so factoring wise, unless dots would work, which it wouldn't, I'm going to leave 2x minus 5 as part of the top. Now, 2x squared plus 3x minus 5, that's a trinomial. It does not have a GCF, so I'm going to have to use our trinomial with grouping technique to factor it. So on the top, we'd have negative 10. The bottom will have positive 3. We need 2 numbers that multiply to negative 10 but add to positive 3. 5 and negative 2 should get that job done. So we can rewrite this as 2x squared plus 5x minus 2x minus 5. We're just rewriting this plus 3x as plus 5x minus 3x. And then we group. So we'll look at the first 2 terms. Common factor there is going to be x. The second 2 terms, common factor here is just going to be a negative 1. So then the signs change and we get the same common factor with both of those. So the top, the 2x squared plus 3x minus 5, I can rewrite as 2x plus 5 times x minus 1. Now for the bottom. This first quantity here, 4x squared minus 25, we can use dots, so 2x plus 5, 2x minus 5. And the x plus 3 is done at this point. So now what I want you to do is pause the video, cross out common factors, and think about how you would rewrite your final answer.